Welcome to this session. In this session, we talk about the classical optimization. So we shall talk about the comparative statics. Comparative statics is a method that is used in economics and many other social sciences to analyze the changes in an economic system or a particular variable when one or more parameters are changed. It uses the concept of differential calculus to study the changes in a system and to determine the relationship between variables. So in comparative statics, the derivative of a function is used to determine how a change in one independent variable affects the value of the dependent variable. So by examining the signs of derivative, economics can determine whether a change in one parameter will lead to a change or to an increase or decrease in the dependent variable, and by how much. So for example, comparative statics can be used to analyze the effect of a change in a government policy on the supply and demand for a particular good or service. The economist can use the derivative of the supply and demand function to determine how changes in the price of the goods and other parameters will affect the quantity supplied and demanded. So in general, comparative statistics is a useful tool for economists used to analyze changes in an economic system and the relationship between variables. So it uses the concept of differential calculus to determine the effect of changes in parameters on the dependent variable and provide a framework for understanding the dynamics of an economic system. So suppose that a company produces a certain product and the demand for that product is given by the function P is equals to 150 minus 2x, where in this case P is the price of the product and X is the demand. So in this case, the price will go up the price will go up when or rather the demand normally will be expected to go up if the price is low and vice versa. Now the company's cost of producing the product is given by the function C is equals to 10x plus 100. So in this case, here, the variable cost per unit is 10, while the fixed cost is 100. So the company, in this case, wants to find the quantity that maximizes its profit Z, where the profit in this case is given by the difference between its revenue and the cost. The revenue is the proceeds from sales. When you sell your products, you get the revenue. So in this case, the revenue R can be expressed as the price of the product times the quantity that you sell. If the price is P, then you sell X items, then the revenue generated, the total amount that you get from the sales will be the price of the product times the quantity sold. The profit, on the other hand, is obtained by subtracting from revenue the cost of production. So when we take the revenue and subtract the cost, what you get is the profit, which we shall denote by Z in this case. So we write Z is equals to the revenue minus the cost, which is P times X, minus C. So the problem here is to use differential calculus to find the quantity that maximizes the company's profit. So the first step in this case is to find the profit function, which we have said is given by the revenue minus the cost. So this is the price times quantity minus the cost. Remember, Z, when we write P times X minus C, we can also substitute C is equals to 10X plus 100, and P is 150 minus 2X. So we shall substitute these two here. P is that, and C is this. So when we substitute and simplify, we get Z is equals to minus 2X squared plus 140 minus 100. So this is the profit function. So to find the point or the value of X for which the profit is a maximum, we simply need to differentiate Z with respect to X. So we find the first derivative of the profit function, and we call this the marginal profit. So dz by dx is equals to minus 4x plus 140. Next, we equate this to 0. So we get minus 4x plus 140 is equals to 0. So that 4x is 140, and therefore x is 35. So that the company should produce 35 units to maximize its profit. So this is an example of how differential calculus can be used in comparative statistics to analyze the changes in an economic system and to determine the relationship between variables. So in this case, we use differential calculus to find the quantity that maximizes the profit of this company, which is a common problem in comparative statistics. We also have problems in revenue and profit functions. So in business, revenue, what we have talked about as the proceeds of sale, or what we shall call turnover, is the income that the company receives from its normal business activities. That is, it is the proceeds from the sale of goods and services. So it is usually obtained by multiplying the price at which the goods or services are sold by the number of units sold. So if we denote P by, if we let P denote the price of a commodity and X the quantity sold, then the revenue R will be given by P times X. So that if Cx denotes the cost of producing X units, then the profit function Zx will be given by revenue minus cost. So that's the profit function. So this equation will represent the decision maker's objective function. And normally, because this is the profit, then one seeks to find the value of X for which Z is a maximum. That is to find the level of output for which the profit is a maximum. So suppose you are told to find the level of Q, which maximizes the profit Z. So here we are given the profit function. So we simply need to find dz by dq. In this case, it will be 1200 minus 2q. And to find the point where z is a maximum, we equate this derivative to 0. And so in this case, q is 600. And if we find the second order derivative, d squared z by dq squared, then we see this will be minus 2, which indicates that z is a maximum. So we have a second example. A company has established through the statistical demand analysis that the demand X of the product is related to the price P by the equation X is equals to 1000 minus 4P. Or the cost C of the product is related to the demand by the equation C is equals to 6,000 plus 50x. And the problem is to determine the price P that the company should charge to maximize its profit and the total profit that the company will earn from this product. So again, the profit is given by revenue minus cost, where revenue is P times X, where P is the price. So we can write, in this case, Z is equals to P times X minus 6,000 plus 50x. This is the profit function. So when we open the brackets, we get px minus 50x minus 6,000. But remember, we have x is given as 1,000 minus 4p, so that we can substitute that. Where we have x, we can replace with 1,000 minus 4p. We have x here and here. Then we simplify. This should give us minus 4p squared plus 1,200p minus 56,000. Then we find dz by dp, which is minus 8p plus 1,200. For a maximum profit, dz by dp must be equals to 0. So we equate minus 8p plus 1,200 to 0, and then solve the resulting equation. And this gives p is equals to 150. This is the price for which the maximum profit is attained. So the maximum profit, we can now substitute. Z is equals to minus 4p squared plus 1,200 p minus 56,000. We substitute p is equals to 150 in this equation to get the maximum profit. At the maximum profit, when we do that, we get 34,000. So basically, this is how we solve the problems of profit maximization. So thank you for watching. And in the next videos, we shall be talking about the partial derivatives.